At 6:47 a.m. on June 6, 1944, steel ramps dropped on Omaha Beach and men ran into machine gun fire. Within hours, 156,000 Allied soldiers were attempting to secure a foothold on the coast of Nazi-occupied France. Every rifle they carried, every tank that rolled off a landing craft, every field radio that crackled with orders across the smoke-filled beach, each one was held together by screws. Small, unremarkable, easily overlooked. The kind of thing no general mentioned in a dispatch. The kind of thing no soldier thought about while running for his life across wet sand. But without those screws, none of it worked. The rifle jammed. The tank fell apart. The radio went silent. A modern army in 1944 was, at its core, a machine, and a machine is only as strong as its smallest fastener. This is the story of how a single factory complex in Chicago produced over 2 billion screws, bolts, and fasteners between 1941 and 1945. How a company that had spent decades making screws for refrigerators and automobiles retooled overnight to become one of the most critical suppliers in the American war machine. How 12,000 workers, many of them women, many of them immigrants, most of them people history has since forgotten, worked 3 shifts a day, 7 days a week, for 4 years, and produced the hardware that held the Second World War together. The problem nobody wanted to admit. The problem began long before Pearl Harbor. In 1939, as Germany swept through Poland and Europe began to understand what modern industrial warfare actually looked like, American military planners faced a quiet, embarrassing reality: the United States did not have a coordinated system for producing the small hardware components that military equipment required. Aircraft required thousands of precisely machined screws per plane. A single B-17 Flying Fortress used over 300,000 individual fasteners. A Sherman tank required approximately 650,000. A destroyer escort vessel needed more than 1 million. These were not exotic components. They were standard parts, threaded, drilled, shaped to tolerances measured in thousandths of an inch. But they had to exist in quantities the country had never attempted to produce. The military's procurement officers surveyed existing production capacity in 1940 and came back with numbers that alarmed even optimistic planners. Existing American fastener manufacturers could produce roughly 400 million screws annually across all civilian and military demand combined. The projected military requirement for full wartime production was over 3 billion screws per year. The gap between what existed and what was needed was not a rounding error. It was a chasm. Someone had to fill it. And the military, as it often does in wartime, turned to the people who already knew how. The man who built the machine. In Chicago, a 58-year-old engineer named Oscar Fisher had spent 30 years thinking about one thing: how to make metal screws faster, more precisely, and more cheaply than anyone else in the world. He was not a glamorous figure. He did not write letters directly to admirals. He did not make bold promises in Navy conference rooms. He ran a factory, the Illinois Tool Works facility on Elston Avenue, and he ran it with the kind of obsessive precision that manufacturing men of his generation either possessed completely or not at all. Fisher had joined Illinois Tool Works in 1911 when the company was already decades old, founded in 1897 to produce specialized cutting tools and industrial fasteners for Chicago's booming manufacturing sector. By the time the Depression hit, Fisher had worked his way from the factory floor to the engineering department to senior management, and he had spent those years doing something few of his contemporaries bothered to do: he had studied production itself as a science. He had read Frederick Winslow Taylor. He had visited Ford's River Rouge plant and stood for hours on catwalks above the assembly lines, watching how continuous flow production eliminated the dead time between manufacturing steps. He had corresponded with engineers at Krupp in Germany before that became inadvisable, and learned how European manufacturers had pushed screw-making machinery to speeds American factories hadn't attempted. By 1940, Fisher understood something important: the machines that made screws were not running anywhere near their theoretical limits. They were running at the speed tradition and caution had established. That speed was about to become irrelevant. Building a factory inside a factory. When the War Production Board approached Illinois Tool Works in late 1941 with preliminary production contracts, Fisher had already been preparing for 4 months. He had not waited for contracts. He had spent his own company's capital, $2.3 million, a sum that represented years of retained earnings, converting floor space, ordering new header machines and thread rollers, and redesigning the production flow of the Elston Avenue facility. The existing factory occupied 4 buildings along a 3-block stretch of the Northside Industrial Corridor. Fisher leased 3 adjacent warehouses and began connecting them. By January 1942, construction crews were cutting holes through brick walls and installing conveyor systems that ran from one building to the next. The factory did not shut down during the conversion. It kept producing civilian fasteners in some sections, early military contracts in others, construction work happening around both. The new layout was built around a single organizing principle Fisher called the river system. Raw steel wire arrived at one end. Finished, inspected, packaged screws left at the other. Between those 2 points, nothing stopped moving. The wire went to the cold heading machines, where high-speed hammers shaped the blank heads at rates of 400 pieces per minute. The blanks moved to thread rolling stations, where hardened dies pressed helical grooves into the shanks without cutting away material, a process that was both faster and stronger than thread cutting, because it compressed the steel rather than removing it. The threaded blanks moved to heat treatment, then to inspection, then to packaging. At full capacity, the combined facility processed 47 tons of steel wire per day. That wire entered as spools and left as screws, approximately 6 million finished fasteners every 24 hours. The workers who ran it. The machines required workers. Illinois Tool Works in 1941 employed approximately 3,400 people across its Chicago operations. By the summer of 1943, that number had grown to 12,000. Fisher hired anyone willing to learn. He hired the wives of men who had shipped out to basic training. He hired recent immigrants from Poland, Italy, and Mexico who had arrived in Chicago with strong backs, no English, and no manufacturing experience. He hired black workers at a time when most Chicago manufacturers maintained informal color lines, not from progressive conviction alone, but because he needed bodies on the line and he was not willing to leave talent unused. Training took 2 weeks. Not because Fisher was cavalier about quality, his inspection standards were the strictest in the industry, but because the work itself, though demanding, was learnable. A worker on a cold heading machine did not need years of experience. She needed to understand the machine's rhythm, recognize the sound of a properly formed head versus a defective one, and develop the hand-eye coordination to keep pace with a mechanism running at 400 cycles per minute. 2 weeks was enough to learn the job. Months of repetition made someone fast at it. Women made up 47% of the workforce by mid-1943. Many had never worked in manufacturing before. Some had never worked outside the home at all. They learned to operate presses and rollers and heat treatment furnaces. They learned the micrometer and the thread gauge, instruments of precision that measured in 10,000ths of an inch. They became, in the matter of months, some of the most skilled production workers in one of America's most exacting industries. The factory ran 3 shifts, 8 hours each. The day shift arrived at 6 a.m. and left at 2 o'clock in the afternoon. The evening shift ran from 2 to 10 o'clock. The night shift ran from 10 p.m. to 6 a.m. The machines ran continuously. The only time they stopped was for scheduled maintenance, which Fisher insisted happened during shift transitions so no production time was lost. Maintenance crews worked in 15-minute windows between the departing and arriving shifts, lubricating, adjusting, replacing worn dies. Then the next shift came on and the machines resumed. What 2 billion screws actually means? The number is difficult to hold in the mind. 2 billion screws. If you laid them end to end, they would circle the Earth approximately 12 times. If you stacked them in a column, they would reach roughly 40 times the height of Everest. These are the kinds of comparisons people reach for when numbers become too large for intuition, but they don't quite capture what 2 billion screws actually meant in 1942 through 1945. What it meant, practically, was this: 1 in every 14 military fasteners used by American forces came from the Illinois Tool Works complex on Elston Avenue. It meant that somewhere in every aircraft the Army Air Forces flew, in every vehicle the Army drove, in every gun the infantry carried, somewhere in that equipment were screws that had been headed and threaded and inspected in Chicago by workers who would never see the machines those screws held together. The types of fasteners the factory produced shifted constantly with military requirements. Early in the war, the largest orders were for standard machine screws, the simple fasteners used in small arms, field equipment, and vehicle components. By 1943, the contracts expanded to include specialized aviation fasteners, close-tolerance screws made to tighter specifications than anything in civilian use, because at altitude and under vibration, a fastener that would be perfectly acceptable in a refrigerator could fail catastrophically in an aircraft engine. Fisher hired a metallurgist named Dr. Harold Brower in 1942 specifically to develop alloy specifications for aviation fasteners. Brower's team produced 17 new specifications over 3 years, each one solving a specific problem: brittleness at low temperatures, stress corrosion in salt air environments, fatigue failure under repeated loading cycles. The screws that came out of the heat treatment furnaces in 1944 were fundamentally better fasteners than the ones being made in 1941, not because the machines had changed, but because the metallurgy had advanced. The inspection line. At the far end of the production flow, before packaging, sat the inspection line. This was the section of the factory Fisher visited personally every morning, regardless of what else demanded his attention. Quality was not a secondary concern at Illinois Tool Works. It was the constraint around which everything else organized. Military specifications required that fasteners meet dimensional tolerances of plus or minus 0.002 inches on critical dimensions. A screw that was slightly too long could prevent an assembly from seating properly. One that was slightly undersized could strip its mating thread under load. The military's acceptance sampling procedures required that a lot of 100,000 screws contain no more than a specified number of defectives, and for aviation applications, that number was effectively zero. The inspection line employed 1,400 workers by 1944, more than 1 in 10 of the factory's total workforce. Every one of them was trained to use gauges and to recognize defects by sight and touch. Every batch of finished screws passed through both automated gauging and human inspection before it was accepted. Fisher's rejection rate, the percentage of finished product that failed inspection and had to be scrapped, ran below 0.3%. This was not industry-leading. It was several times better than industry-leading. It was a standard he had set and refused to lower even under the pressure of accelerating production quotas. There were arguments about this. War Production Board officials visited the plant in 1943 and suggested that Fisher's inspection standards were excessive for non-aviation military applications and were adding unnecessary cost and time to production. Fisher listened to the argument, thanked the officials for their visit, and maintained his standards. His position was simple: he did not know which screws were going into aircraft and which were going into desk drawers in a supply depot. He was not willing to find out by waiting for a failure. The human cost of the line. The factory was not a comfortable place to work. Summer temperatures on the production floor regularly exceeded 100 degrees, driven by the heat of the machinery and the bodies of several thousand workers in an inadequately ventilated space. Fisher invested in cooling systems in 1943, large exhaust fans and evaporative coolers along the rooflines, but they reduced the temperature rather than solving it. Women working near the heat treatment furnaces learned to soak their cotton work gloves in cold water between batches. It helped for a few minutes. The noise was constant and physical. Cold heading machines operating at 400 cycles per minute created a percussion that workers described not as sound but as pressure, something felt in the chest and jaw as much as heard. The factory provided ear protection, cotton plugs that workers were issued at the start of each shift and trained to use. Many didn't. The plugs interfered with the ability to hear the subtle changes in machine sound that indicated a worn die or a feeding problem. Workers learned to diagnose their machines by ear, and they sacrificed the hearing that made that diagnosis possible. Injuries happened. Press machines and thread rollers were unforgiving of inattention, and attention is difficult to sustain across 8-hour shifts of repetitive work. The factory's medical station treated an average of 23 workers per day in 1943, mostly cuts, crush injuries to fingers, and burns from the heat treatment operations. Fisher implemented a safety program in late 1942 that added guarding to the most dangerous machines and created formal procedures for die changes and equipment maintenance. Injury rates fell by 40% over the following year. They did not reach zero. Workers understood the stakes. They read the newspapers. They had husbands and brothers and fathers in uniform. A woman named Rosa Alvarez, who worked the thread rolling line from 1942 through 1945, later recalled in an oral history interview that she thought about her brother in the Pacific every time she looked at the screws coming off her machine. Her brother was a mechanic with the Army Air Forces. He spent his days keeping aircraft flying. She spent her days making the fasteners that held aircraft together. They never discussed this directly in the letters they exchanged during the war. There was, she said, nothing to say. They both understood. The supply chain nobody saw. Illinois Tool Works did not operate alone. The factory consumed 47 tons of steel wire per day, and that wire had to come from somewhere. It arrived from mills in Gary, Indiana, and Pittsburgh, Pennsylvania, steel wire drawn to precise diameters that the cold heading machines required. If the wire varied by more than a few thousandths of an inch in diameter, the heading dies produced defective blanks. Fisher maintained specifications for incoming wire that were, at the time, the tightest in the American fastener industry, and he worked directly with the mill engineers to ensure compliance. The relationship between the Chicago factory and the steel mills became, over the course of the war, a continuous engineering conversation. Problems that showed up in finished fasteners were traced back to wire characteristics. Wire quality issues were traced to mill processing conditions. Solutions developed for one problem revealed others. The supply chain learned, collectively, how to produce better raw material for a faster and more demanding production process. The knowledge generated in that exchange did not disappear when the war ended. It remained in the practices and specifications of both the fastener manufacturers and the steel mills, raising the baseline quality of American industrial production for decades afterward. After the last contract, Japan surrendered in September 1945. Military contracts ended within weeks. Illinois Tool Works, which had been producing 6 million fasteners per day for the American military, watched its order books empty in a matter of months. The factory went from 12,000 workers to 4,200 by the end of 1946. The women who had made up nearly half the workforce largely left, some because they wanted to, some because the culture of the time expected it, some because the jobs simply no longer existed. Fisher retired in 1948. He had run the Elston Avenue operations through the entire war production period and through the painful demobilization that followed. A small ceremony in the company cafeteria marked the occasion. He received a watch and a framed letter of commendation from the War Production Board. The Chicago Tribune ran a 4-paragraph item about his retirement on page 18. He died in 1957, largely unknown outside the industry. The factory itself continued producing fasteners for automobiles, appliances, construction, industry, and grew again through the post-war boom. Illinois Tool Works became, over the following decades, one of the largest diversified manufacturers in America, a company measured by billions in revenue and operations on every continent. The Elston Avenue facility was eventually absorbed into the larger corporation and the site was redeveloped in the 1980s. A parking structure occupies part of the original footprint today. What a screw is worth. General Eisenhower, when asked after the war what had most surprised him about American industrial capacity, spoke about production numbers, the aircraft, the tanks, the ships. He named the big things. He mentioned Andrew Jackson Higgins and his landing crafts. He talked about the arsenals and the shipyards. He did not mention screws. He never would have. No one thinks about screws. That is precisely the point. A screw is so fundamental to the operation of machinery, so universal in its presence, so small in its individual contribution, that its absence only becomes visible when the machine stops working. The 2 billion screws produced on Elston Avenue never appeared in a headline. No war correspondent filed a dispatch about them. No newsreel showed their production. They simply existed in the rifles, the tanks, the aircraft, the radios, the artillery pieces, the ships, and because they existed, those larger machines functioned. The workers who made them knew their work mattered. They didn't need headlines to tell them. They had brothers in the Pacific and husbands on Omaha Beach, and they understood, in a way that did not require explanation, that the quality of their work was connected to whether those men came home. That knowledge was not comfortable. It was a weight carried through 8-hour shifts in a hot, noisy factory. It came home with them at night and sat at the kitchen table. It woke them before the alarm. It was a form of responsibility that most people in most times never carry, and it was borne, quietly, by 12,000 workers in Chicago for 4 years. Most of them are gone now. The workers died decades ago. The factory was demolished. The machines were scrapped or sold. The 2 billion screws rusted into the machinery they held together and were replaced and forgotten, the way fasteners always are. But their contribution remains woven into every history of industrial mobilization, present in every account of how America fought and won the largest war in human history. Eisenhower said Higgins won the war. He was right. But Higgins needed screws to hold his boats together. And those screws came from Chicago, from the hands of workers who never saw the ocean, who never received a medal, who returned to their factory floors every morning for 4 years because they understood that the precision of a thread, the integrity of a head, the tolerance of a dimension measured in 10,000ths of an inch, that these things mattered. That the difference between a screw that held and a screw that failed was the difference between a weapon that fired and a weapon that didn't. Between a machine that held together and one that fell apart. Between a soldier who came home and one who didn't. That is what 2 billion screws are worth. That is the legacy of a factory that history forgot. Not just the hardware, but the proof of what ordinary people, given an impossible task and a clear reason to accomplish it, are capable of building, one small, precise, unremarkable fastener at a time.